Collection, examination, and chemical analysis of paint evidence. So paint evidence that you find can come in a bunch of different forms. You might find loose chips of paint. Say, for example, if you dragged a crowbar across my walls, you might find chips of paint that have flaked off of the wall from when you dragged that metal crowbar across it. You might find paint embedded on other surfaces. Remember Locard's exchange principle. If I take a baseball bat and I know you can't see it in here in my office, but I have this bright peacock blue wall, like an accent wall. If I take a regular old baseball bat and I hit that accent wall, there's going to be a little bit of wood scuff on the wall, and there's going to be some of that paint on my baseball bat as well. That paint on my baseball bat is going to be pretty well embedded, or at least some flakes of it will be pretty well embedded. I'd have to take sandpaper to it to get it off. You'll always need a standard reference sample, and you'll never commingle paint chips from the same source. For loose chips, you'll gather up your evidence by using forceps or a paper scoop. And a paper scoop is exactly what it sounds like. You take a little piece of paper, usually round, you turn it into a scoop shape or like a U shape, and you just scoop under it, and so that you can transfer it into your packaging. Your packaging is typically going to be paper if you get a paint sample wet, or if there's any kind of moisture on the paint sample, it's going to bleed that paint onto other types of evidence onto the outside of the container, and it can disrupt any kind of layering that you might find on the paint later on if you have one layer that bleeds because it got wet. So you're going to want to make sure your container is breathable. Druggist fold works beautifully for this purpose. If you have embedded paint on other surfaces, you're going to have to package up the whole item. That baseball bat is going to have to go in its own bag by itself with that paint on it already. And again, you're never going to commingle paint chips even if you think they're from the same source. If I have a car, like let's pretend I have a white car, and I got hit with a shopping cart in the Target parking lot. Those shopping carts are bright red. I might have a bright red streak down the side of my car. If I also got T-boned by a red pickup truck later on, I'm going to have red streaks on the side of my car. An undiscerning eye would look at those and say, oh, they're all red streaks. They're all probably from that truck. But they might be from different sources. So you don't want to commingle those just in case they happen to be different. Comparison microscopy is going to be a really useful type of technology. It's simple, it's straightforward, but it's still really, really useful. And of course, you're always going to need a standard reference sample. So your evidence sample is going to be taken from where you see the actual cross transfer of evidence. And then from this car, so you have all this white paint over here, you will also take a standard reference sample from somewhere uninvolved in this, in the collision somewhere else on the car. You'll take a sample from there. Same thing with who you think has that red car. If they say it was my next door neighbor, that jerk is always driving like a bat out of hell down my road, and he clipped me when I was coming out of my driveway, they can go to that guy's car, take a standard reference sample from his, look for white streaks on his pickup truck, and see if they match. By comparison microscopy, when you look at them side by side, you can examine them for color, texture, patina, etc. Is it pearlescent? Is it flat? Is it glittery? Is it grainy? Is it gritty? Is it very smooth? Is it a bright cherry red, or is it maybe like a raspberry red, or is it more like a magenta? And you can characterize it pretty well. Remember, when you have car paint, you have potentially transfer of a bunch of different layers. You can look at those layers sideways and see the stacking up of those layers from the bottom electrocoat primer, hopefully, all the way up to the clear coat and whatever else might be in between. There's times with your cars that you'll have more than those 4 layers. Those are just the 4 layers that every car always has. The more layers you can match up between samples, the more reliable your assertion would be that they might come from the same place. Keep in mind that layers might fragment off unevenly, so you're not necessarily taking a good, fully, equally deep sample for every collision, or every time you take a sample. You're going to probably want to get a few different samples to have a good representative picture of what was involved. A chemical analysis test is just a solvent test. So all of these different paints and all these different primers will dissolve in the when exposed to different kinds of solvents. This is a really straightforward type of test. You isolate the paint that you want to test. You think it's made up of X chemical, or you think it came from X place and therefore is made of this certain type of paint. You find a solvent that you know can dissolve that paint, and you apply the solvent to the paint and see if it works. And if it doesn't work, you can look for other properties that might be characteristic of how it reacts to the solvent you chose. Maybe it doesn't dissolve exactly, but it softens, so you could peel it off. Maybe it curled up, maybe it swelled up. What does it do in exchange when exposed to that chemical? This does destroy your evidence though, and so you only want to do this if you have more evidence left over to use for comparison microscopy or for some of the more sophisticated light-based techniques that we'll talk about in a different slide.